x is equal to 20t cubed over 3 minus 23t squared over 2 plus 6t plus 5 represents the distance x meters moved by a body in t seconds. Grace and peace to you all, and welcome back to my channel. This is Donald C. I'm an author of A Hidden Mathematical Genius Within Revealed. Okay, so today's question is on application of calculus with regards to kinematics. We have a function, a distance function, that is x is equal to 20t cubed over 3 minus 23t squared over 2 plus 6t plus 5. So this is a distance, and we are told to find determine the velocity and acceleration at the start. Velocity and acceleration at the start. Okay, so if you go by physics definitions, we know that velocity is the change in distance with respect to time. Change in distance with respect to time. That is velocity. And in terms of calculus, it means that is the differentiation of x in terms of t. Differentiation of distance with respect to time. Okay, so we have velocity is equal to derivative of x with respect to time. So this is equal to, so the derivative of 20t cubed over 3, we're going to have 3 multiplied by 20 over 3, 3 and 3 will cancel out, so you get 20, then 3 minus 1, that is 2. So we have 20 t squared minus 23 squared over 2, derivative 2 multiplied by 23 over 2, 2 and 2 will cancel out, so you get 23. So it's 23, then 2 minus 1 is just 1, so you get t. Then derivative of 6t is just 6, so plus 6. Derivative of a constant, this is 5, derivative of a constant is just 0. So the expression for velocity is 20t squared minus 23t plus 6. Now we are told to find velocity at the start. So if you say velocity at the start, it means time should be 0. So we need to find velocity when t is equal to 0. So you say v of t is equal to 0 is equal to 20 t is 0. So 20 0 squared minus 23 t is 0. So 23, then we have 0 squared plus 6. Okay, so v at t is equal to 0 is equal to, okay, so 0 squared is just 0. 0 multiplied by 20 is just 0. 0 squared is just 0. 0 multiplied by 23, you get 0, then plus 6. So this is just equal to 6. Okay, so the unit should be meters per second. So that is velocity when t is equal to 0, that is at the start. So we go to acceleration. What is acceleration? Okay, so acceleration is the change in velocity with respect to time. In terms of calculus, it means the derivative of velocity with respect to time. Okay, so our expression for velocity is v is equal to 20t squared minus 23t plus 6. Okay, so we need to find an expression for acceleration from the function of velocity. Okay, so acceleration is equal to derivative of v with respect to time. Okay, derivative of velocity with respect to time. So dv dt. So this is equal to derivative of 20t squared. 2 multiplied by 20 is 40. So we have 40. 2 minus 1, that is 1. So we have 40t minus derivative of 23t is just 23. Derivative of 6 is a constant. Derivative of constant is always 0. Okay, so an expression for acceleration is 40t minus 23. Again, we want to find acceleration at the start, meaning again t is 0. Okay, t is 0. So acceleration when t is equal to 0 is equal to 40. So t is 0, so you put a 0 there, minus 23. Okay, so acceleration is equal to 40 multiplied by 0 is 0. Then you get minus 23. So you get minus 23 meters per second squared. Okay, so those are the two solutions. Velocity at the start is 6 meters per second, and acceleration at the start is minus 23 meters per second squared. Okay, B, you find the velocity and acceleration when t is equal to 5 seconds. Okay, so this is simple. We already have the function for velocity and acceleration. Okay, so we have velocity when t is equal to 5 seconds. That's B. So velocity, the velocity function was calculated as v is equal to 20t squared minus 23t plus 6. Okay, so we want to calculate velocity when t is equal to 5 seconds. So meaning where there is t, you just put a 5. So v at t is equal to 5 is equal to, so we have 20 at t is 5. So 5 squared minus 23, t is 5, then plus 6. Okay, so v at t is equal to 5 is equal to we have 5 squared. 5 squared is 25. 25 times 20. Okay, so 25 times 20, you get 500. So we have 500 minus 23 times 5. 23 times 5, you get 115. Then plus 6. Okay, so v at t is equal to 5 is equal to, so we have 500 minus 115 plus 6, you get 391. So this is 391 meters per second. That is when t is 5 seconds. Okay. Then acceleration. We have acceleration when t is equal to 5 seconds. So again we have an expression for acceleration. That is, acceleration is equal to 40t minus 23. Okay, so its acceleration when t is equal to 5, that is 40, then t is 5, and minus 23. Okay, acceleration is equal to 40 times 5, that should be 200. Yes, we have 200, then minus 23. So 200 minus 23, you get 177. So acceleration is equal to 177 meters per second squared. Okay, so we are on C. Find the values of t when the body is at rest. Okay, so when the body is at rest, meaning it is not moving, and when it is not moving, you can say velocity should be 0. So we are going to equate we are going to use the function for velocity and put a 0 where there is v. Okay, so we found an expression for velocity as v is equal to 20t squared minus 23t plus 6. Okay, so since the body is at rest, it means v will be 0. So 20t squared minus 23t plus 6 is equal to 0. And we can see that this is a quadratic equation, and we can use factorization method. Okay, so we can see that the product will be product is 20 multiplied by 6, that is 120. Product is 120, and the sum is minus 23. So we need to find two factors of 120 whose sum is minus 23. Okay, we know that minus 15 minus 8, you get minus 23, and minus 15 multiplied by minus 8, you get 120. Okay, so where there is minus 23, you put minus 15 minus 8. So we have 20t squared minus 15t minus 8t plus 6 is equal to 0. Okay, then we factorize by grouping terms. So if you get these two, 20t squared and 15t, what is common? Okay, we can see that 5t is common, so we divide out 5t. 20t squared divided by 5t, you get 40 minus 15t divided by 5t, you get 3, so that is minus 3. Okay, so in minus 8t and 6, what is the highest common factor? Okay, the highest common factor will be minus 2. Okay, minus 2. Minus 8t divided by minus 2, you get 40. 6 divided by minus 2, you get minus 3. This is equal to 0. So we can see that 40 minus 3 is common. So we divide out 40 minus 3. So 40 minus 3. When you divide out 40 minus 3 here, you remain with 5t. You divide out 40 minus 3 here, you remain with minus 2 is equal to 0. So we have the product of 4t minus 3 and 5t minus 2 is equal to 0. So it means if the two product, the result is 0, it means one of the two should be 0. So either 4t minus 3 is equal to 0, or 5t minus 2 is equal to 0. Okay, then we solve for t. Okay, so here for us to remain with a term having t, we need to get rid of minus 3 by adding 3 to both sides of the equation. So here when you add 3, it will cancel out with a minus 3. So we are going to have 4t is equal to 0 plus 3, that is 3. Then for you to remain with t, you divide through 4. So over 4 over 4. So t is equal to 3 over 4 seconds. Or come this side, this is 5t minus 2 is equal to 0. So for you to remain with a term having t, we need to get rid of minus 2. And to get rid of minus 2, we do the opposite of minus 2. And the opposite of minus 2 is plus 2. So we add 2 to both sides of the equation. Plus 2 here will cancel out minus 2. So we have 5t is equal to 0 plus 2, you just get a 2. Then to remain with t, you divide through 5. So over 5 over 5. So t is equal to 2 over 5 seconds. So the two values of t when the body is at rest are t is equal to 3 over 4 seconds, or t is equal to 2 over 5 seconds. Okay, so we are on t. The value of t when the acceleration is 45 meters per second squared. Again, we have the function for acceleration. Okay, so c acceleration is equal to, we had 40t minus 23. Acceleration is equal to 40t minus 23. Okay, so we want to find when the acceleration is 45 meters per second squared. So where there is a, we just put 45. Okay, so 45 is equal to 40t minus 23. Okay, so we are solving for t. So for us to remain with a term having t this side, we need to get rid of minus 23, and the opposite of minus 23 is plus 23. So we add 23 to both sides of the equation. Plus 23 here will cancel out the minus 23. So you get 40t is equal to 45 plus 23. 45 plus 23. 45 plus 23 you get 68. So we have 68. 40t is equal to 68. Okay, then for us to remain with t, we divide 40 to both sides of the equation. So over 40 and over 40. So 40 and 40 cancel out. T is equal to 68 divided by 40. 68 divided by 40, you get 1.7. So we have 1.7 seconds. So that is the value of t when acceleration is equal to 45 meters per second squared. And the last one, the distance traveled in the third second. We have the function for distance. Okay, the function for distance is x is equal to 20t cubed over 3 minus 23 t squared over 2 plus 6t plus 5. Okay, so we want to find the distance traveled in the third second, meaning when t is equal to 3. Okay, when t is equal to 3. So we are going to have x at t is equal to 5 is equal to, so we have 20 t is 3 cubed over 3 plus 23 over 2 t is 3, so we have 3 squared plus 6 multiplied by 3 plus 5. Okay, so we have x at t is equal to 5 is equal to, so 3 cubed is 27, 3 in 27, that is 9 times 20, you get 180 plus 3 squared is 9 times 23, you get 207, divide by 2, you get 103.5 plus 3 times 6 is 18, then plus 5. Okay, so distance when t is equal to 5 is equal to, so we have 180 plus 103.5 plus 18 plus 5, so we get 306.5 meters. 306.5 meters. So those are the solutions. Thank you so much for your time.